All right, so the math dealer here, and today we're going to talk about parent functions. Okay, so parent functions are those standard functions that you see in every single one of those math courses over and over and over. Basically, they show up a lot with Algebra 2, all the time in pre-cal, but we use them in calculus to kind of get like references, like just to try to be like, oh, we know what this graph looks like this, and this graph looks like this. So you really do have to be pretty proficient in understanding like what these graphs look like, the domains and the ranges. Okay. So a linear function, right? That's our classic line. So if we just have a good old fashioned linear function, it's going to look like that. Hopefully your line will be a lot better than my line. I could probably use this little tool here. Wouldn't that be clever? Look how fun I am. I know you're like, really, math dealer? You don't have to worry about that. But just for fun. Anyway, so that's pretty much what the parent function is going to look like for that for a line, right? Y equals x. Now, of course, if the slope was negative, we'd be going the other way. But remember, we're not doing any kind of transformations with these guys. We're just basically saying, hey, graph y equals x. And honestly, in our function world, we really are going to write f of x equals x. Okay, don't be scared of f of x, right? F of x is like saying y. All right, quadratic functions. Yes, the parabolas come into play, right? So parabola, as we know, a degree of 2 makes a u. And of course, like I said, it should just be a good old-fashioned u, but I'm drawing this free-handed, so Lord knows we have no idea what's going to show up. Anyway, but degree of 2's make u's. What degree we're talking about is those exponents. Just take note, though, my domain is no longer the same as my range. The domain is all reals, but the range is only positive from only positive numbers, 0 to infinity. Okay, odd degree polynomials. So that's like if we're graphing like y equals x cubed, right? So I always say y equals x cubed is pretty much the snakes going up the pole, if that makes sense. And I don't mean to be rude about snakes, but they're like slithering on up. Yes, we can shift it. Yes, we can send it the other direction. But bottom line, if I'm graphing y equals x cubed, the graph will start down below and exit out high. Okay. And now, of course, I know I can't help but do it, right? The graph could do that as well. But we're not talking about any of those guys. We're not talking about any ones that have some kind of x-intercepts other than 0. Okay, remember, we're just talking about good old-fashioned odd degree. All right, the larger this number gets, okay, the larger that power gets, like if this was a degree of 5, why isn't that working? This was a degree of 5, then the graph would get a little bit flatter coming in, right? So it's coming up, it flatlines a little bit more and then exits out, okay? The reason being is because literally 5 of our roots are sitting right there at the 0. Okay. So now this guy over here, even degree. So that's like if y equals x to the 4th. We already know what x squared looks like, so don't make me repeat that. However, x to the 4th again comes in, flat lines, and goes back out. Yes, yes, yes. I know that if I have a degree of 4 with other terms, in other words, like if it was f of x is equal to x to the 4th plus blah, 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 x cubed plus blah, 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 x squared, and so forth, right? The graph would basically do, starts up high, comes down, maybe it bounces, who knows? But anyway, regardless, it's going to end top and both up and up. And then, of course, if I start changing the signs, it goes down, down, right? Negative. If I have a negative coefficient, I probably should say that. All right. Okay. Moving right along. Now we're looking at some exponentials. I think I can slide this up. This would be good. There we go. There we go. I knew I could slide it up. Okay. This guy here. If I say, okay, exponentials, right? So an exponential function, those are some of my favorite functions. Wait till you find these derivatives. Oh my God, I'm so excited. Anyway, but regardless, exponentials pretty much goes of that nature, right? Please note exponential functions have horizontal asymptotes. Logarithmic functions have vertical asymptotes. Natural logs, logarithm, any base, pretty much is going to do one of these guys. Reason why, don't forget, the natural log of 1 is 0. Okay, just remember that. The log of any base of 1, of any base, no matter what the base is also 0. Why? Because the base raised to the 0 power is 1. Right? We're going to do lots of logarithms, lots of exponentials. Definitely should know these graphs. Okay, these graphs are important, along with the domain and range. I cannot stress that enough. Okay, I'm going to come back to the sine and the tangent, even though they're very important, but I'm going to jump down to the reciprocal function. The reciprocal function, sometimes referred to as a rational function. Basically, those are the ones that have a vertical and a horizontal asymptote. Okay. Notice it's jumping over zero. It's jumping over zero. Okay, very important. Absolute value. If you had me teaching you algebra 2, you remember absolute value value V. You gotta love that, right? Absolute value functions always have a V shape, not a U. And there is a reason, right? We're going to learn about a lot with calculus with this. The reason why it comes to this V shape is because the derivative, what? Yep, we're going to talk about derivatives, doesn't exist at zero, and we're going to learn why. Okay. All right. Even root functions. Even root functions. Basically, those are the guys like the square root function, right? Oops, I don't know why I did that. Square root function. I always say they're my slow moving curves taking their time. Even if this was like a degree of 4, it still has that slow moving top. Okay. Odd roots. You remember how the odd power was a snake up the ladder or up the pole? Odd root. I always call him the snake through the grass. I know that took me a long time to say all those words. But anyway, so this guy's coming through the grass. I always like to say. Slithering on by. All right. I know, right? If I ever ran into a snake, I would freak out. But anyway, okay. Well, maybe not freak out. Okay. All right. Now let's check out these sinusoidal, cosine, and sine. So these guys here. Remember, A is my amplitude. This is not an ordered pair, right? So I'm going to graph y equals A sine x, right? So if I'm graphing A sine x, when I do that, that basically, remember, the sine wave is up on the origin. And it's going to go as high as A and as low as negative A, right? Remember that? And it's periodic, blah, 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 right? The period of this thing is 2 pi over B. I know you learned about B, but the B in this case is 1, so the period is 2 pi. So every 2 pi, the sign repeats itself. This pattern, though, please note this pattern, okay? Now, when it comes to cosine, the cosine always is our even function. Starts up, did that again. Starts up high, comes down and whatnot, right? And hopefully you remember where these guys hit these peaks and all this. Oh, it's not there. Sorry, that was weird. Right? So basically, it's at 0, and then this piece here, we're sitting at pi over 2. This guy over here is back to pi, and that guy would be 3 pi over 2. And then likewise with the sine wave does that thing. So this is this guy here is my pi over 2. This guy's my pi. And I'm at 3 pi over 2 and 2 pi. I know it's all in your notes. You can go back and look it up. But however, I'm just making sure we are familiar with these. Yes. Yay, team. All right. Now, last but not least, tangent curves sometimes get overlooked. They will not get overlooked in calculus. I promise you, they will not be overlooked in calculus. So the tangent curve, he's the one that has all those dotted freaking vertical asymptotes. Oh my God, I love the tangent. Anyway, looks like this going all the way through. Okay. Just note, and this is one thing they do shush over in algebra. Nah, not even algebra. It's more pre-cal. Vertical asymptotes will take on this form. You might be going, what the heck does that even mean? I want you to look right there. You see that 2n plus 1? No matter as long as n is an integer, right? As long as n is an integer, this number will always be an odd number, okay? If I'm dividing it by 2, okay, this number will still always be an odd number. Excuse me, I shouldn't say that. It'll always be an odd numerator over in number 2. And then, of course, the pi is sitting there. So check it out. And if you don't believe me, just try it out. I just always love this stuff. This is all in like abstract algebra, like when they talk about, anyway, tangent, sorry. 0 goes in, okay, no matter what 0 I put in, I get a 1, right? If I put 1 in, I put 2 in here, 2 times 1 is 2, I get 3. So if you could start seeing, it doesn't matter what I'm putting in here, the number is going to be odd. Because if you double a number and do one more than it, it's always odd, right? That only makes sense. I hope it makes sense. Your vertical asymptotes will always hit at those multiples. Okay. Now, if I start shifting this graph, we're in a whole different ballgame, right? So if I start saying, oh, I want x plus, pi over 4, well, now it's not going to be the case. Okay. So don't think it's always that way. Well, there's a way we can figure out what the vertical asymptotes are going to be, but that's for another lesson. Anyway, all right, so these are all my parent functions. So basically, if I walked in class and I'm like, all right, guys, or girls, whatever, tell me what this is. And you'll be like, oh, it's the absolute value function, right? If they were like, if I showed you this graph and I said, which one is this guy? And you're like, oh, it's x cubed. And then if I said, hey, which one is this one, right? You're like, oh, it's the exponential. Like you just have to be familiar with these shapes. Trust me, it will go a long way. All right, I hope this video was helpful. If not, you can tell me in class. Bye.